Seeing equations of tangent lines. Now that is not a nice looking problem, is it? Right? So let's think about tangent lines in general. We know the equations of lines look like this. Y minus y1 equals m times x minus x1. You could do y equals mx plus b. I think this is probably a nicer way to go. Right? We need a couple of things. We need to know what x1 and y1 are, and we need to know how to get slope. So I guess we can go find the slope first. And to find the slope, you're going to need to figure out what f prime of x is. That's going to equal something. And once you figure that out, we're going to have to find f prime of x when x is equal specifically to 1. Right? So let's give that a shot. So you see that you have a product of functions here. You have a first function and a second function. So we've been remembering the product rule as first times derivative of second plus second times derivative of first. So here's the first function times the derivative of the second. Now it's probably helpful to rewrite this. Think of this as like x to the 1/2 plus x to the negative 1/2. All right. So d second is going to be 1/2 x to the negative 1/2 plus negative 1/2 x to the negative 3/2. Now that's always a source of confusion. If you have to do negative 1/2 minus 1, that's negative 1/2 minus 2 over 2. There's the negative 3 over 2 that you get. It's funny, we do all this complicated math, but the adding and subtracting of fractions always gets us. Okay, so that was first d second plus second, so square root of x plus 1 over the square root of x, d first, and this is a very nice derivative. 3 times 1/3 is 1, so you get x squared, plus 2 times 1/2, right here is 1, then you just get x. The derivative of this x term is just 1, and the derivative of that 1 at the end is 0. Okay, we're not quite done, though, because that's the slope for any x value. Notice how there's x's everywhere. That means that we could plug in any x we want and get the slope at that particular x value. Well, in this problem, we want the slope at 1. 1 is a nice number to plug in, though, isn't it? Right? So this turns out to be 1/3 plus 1/2 plus 1 plus 1. Everywhere there's an x, I'm putting a 1. Times, put 1 in here. 1 to any power is 1. Times 1/2 is 1/2. Plus negative 1/2. And your mind should really be pleased to see this. Right? Take a look at that and tell me, you'll figure out why in a minute. Here you go. Square root of x, square root of 1 is just 1. And then 1 over the square root of 1. If I put 1 here, it's 1 over rad 1. It's just 1. And then this term, 1 plus 1 plus 1. Okay. So this very scary looking derivative that took lots of time yields a very nice answer, because this is just 0. So then 0 times whatever this turned out to be, you might have been worried for a second, oh, I'm going to have to do 1/3 plus 1/2. You don't have to. That's going to be 0. So the only thing that matters is this, but that's 2 times 3, or 6. So 6 is the slope of our tangent line. So we can at least fill that in. Y minus blank equals 6, x minus blank. All right, so we're left with these 2 blank spots, but this one here is easy. That's just the x value we're finding the tangent line, which is 1. Now, to get the y value, don't forget what f of x does. F of x gives us a y value. So we just need to find f of 1. So we're going to plug 1 everywhere in that original function. So if you did that, you'd have 1/3 plus 1/2 plus 1 plus 1, right? That would be 1/3, 1/2, 1, and 1. And then here, you're going to have square root of 1, which is 1, and 1 over the square root of 1. So this ends up being 1/3 plus 1/2 plus 1 plus 1 times 1 plus 1. Okay, so let's see if we can get a little bit of adding done here. So this we could think of as 2/6, and this we could think of as 3/6. All right, so that's 5/6 plus 2. That's really 5/6 plus 12/6, or 17 over 6. So that's this whole first part, is 17 over 6. And we have to multiply that by 2. So 2 times 17 over 6, the 2 and the 6 would reduce, and you get an answer of 17/3. So that's what goes here. And now you have the equation of that tangent line. Okay, so let's try another one. Here we go. Find the equation of the tangent line to f of x equals this function, 1 plus x squared times the cosine of x, at x equals pi over 4. Now, this problem, you'll notice you don't even have the option of multiplying this and getting rid of the product rule. Let me explain what I mean. Back in this question, if we had decided to distribute the rad x onto every term and then go and distribute the 1 over rad x onto every term, we could have done that. It would have been very complicated. We would have done it. We would have had a big, long expression when we're done, and we could have gone through term by term and taken the derivative. And you would not need to use the product rule, this first d second plus second d first thing. In this problem, if you attempt to do that, you get cosine of x. Well, that looks promising, because I know the derivative of cosine of x is negative sine x. But then you get x squared times cosine of x. And so even in our attempt here to distribute, we didn't avoid the product rule, because you're still going to need it for this second part. So you may as well not distribute this thing. I mean, it's up to you, but you might as well just leave it the way it is. All right, so let's go for the derivative first. See what we get. So product rule, here we go. First function times the derivative of the second would be negative sine x. My advice here is put parentheses around that sine x. Otherwise, it's going to look like you're subtracting it, and you don't mean to do that. Plus the second function, cosine of x, times the derivative of the first, is just 2x. All right, so there you go. We really want f prime of pi over 4. So that's going to be 1 plus pi over 4 squared times negative sine pi over 4 plus the cosine of pi over 4 times 2 times the cos times pi over 4. Okay. So I would not expect this thing to look nice when you're done. Try it anyway. So here we go. You get 1 plus pi squared over 16 times the sine of pi over 4 is rad 2 over 2, but this is going to be negative square root of 2 over 2. Plus the cosine of pi over 4 is also square root of 2 over 2. And then 2 times pi over 4 is pi over 2. Okay. Quick side note. Sometimes people forget about things like the sine of 45 degrees, the sine of 30, and all that. Here's a little chart for you that you might like. Here's theta. Here's 30 degrees, 45 degrees, and 60 degrees. And we'll do the sine. Oop, my bad. Hold on a second. We'll do the sine of theta, the cosine of theta, and the tangent of theta. So here's a little chart for you. You might like this. Okay? So sine is going to be 1/2 rad 2 over 2, and then rad 3 over 2. Cosine is the same numbers but backwards. So this is going to be rad 3 over 2, rad 2 over 2, and 1 over 2. If you're interested why, it's because co means complementary. Right? So 30 plus 60 would be 90, and then this would be 45 plus 45, and then 60 plus 30. And then the tangent you get by dividing these. So the tangent here is 1 over rad 3. Here, rad 2 divided by rad 2 is 1. And then rad 3 over 2 divided by 1 over 2 is rad 3. So those are handy little numbers to know. All right. Let's try and simplify this a little bit. Not much is going to happen here. You could think of this as 16 over 16 plus pi squared over 16. So that's really 16 plus pi squared over 16 times the negative square root of 2 over 2. So really, there's not much you can do with that. If you want to distribute this on, you can. It'd be negative 16 square root of 2 minus pi squared square root of 2 over 16 times 2. It's going to be 32. So that's that piece. The other piece just turns out to be, if you look at this, it's pi times the square root of 2 over 4. So is it plus or minus? It's plus. So it's plus pi times the square root of 2 over 4. Okay, you could get a common denominator. We can multiply this top and bottom by 8. So you could get negative 16 square root of 2 minus pi squared rad 2 plus 8 pi square root of 2 all over 32. So this is what f prime of pi over 4 is. I don't know if that looks any better than how it started out, but that's what you can do to it. So let's continue. We know our line looks like this. Y minus blank equals the slope, which would be this thing, times x minus blank. Well, we know that x is pi over 4, so that can go there. And we just need to get the y value. But to do that, you do f of pi over 4. Okay. Well, I got to plug pi over 4 into the original function. So in case you forgot, the original function is 1 plus x squared times the cosine of x. So in our case, it would be 1 plus pi over 4 squared times the cosine of pi over 4. All right, well, this will be a little less messy. This thing we did already. It's 1 plus pi squared over 16, which we already showed is 16 plus pi squared over 16. That's got to get multiplied by the square root of 2 over 2, because that's the cosine of pi over 4. So we end up with, if you distribute that rad 2 onto the top, you end up getting, it doesn't even fit there. I guess I'll start over. I'll write my line again. So y minus, here we go, 16, oops, hold on a second, 16 square root of 2 plus pi squared square root of 2 over 32 equals that slope we had. See if I can remember that. Negative 16 square root of 2 minus pi squared square root of 2. I think it was minus or plus. What was it? Oh, plus 8 pi square root of 2 over 32 times x minus pi over 4. Well, there you go. That's sort of like the epitome of proving to you that you can do this even if the answers are totally ridiculous.